All right. I think I'm live. I'm going to wait about 5, 6 seconds until I can hear myself in the feedback loop on the phone. All right. I think I'm live. I'm going to wait. Okay. Cut off the phone. So what I'm going to do today is really quickly move through one problem. And the one problem is this one. So what I'll do, I'll get the picture first, and I will move it over and drop it right here. Then what we'll do, drop the text right there. And then we're going to pull out my pen, move the keyboard, and just go through this one problem. And then the stream may end a little earlier. So it says, it is observed the skier jumped off the ramp A, which this is the ramp A right there, at an angle of 25 degrees. So go ahead and just say it's 25 degrees. If he strikes the ground at B, which is right down here, determine his initial speed and the time of flight. Okay. So you can just go back to the same concept. Oops, maybe that's, hang on. Let's make it a little smaller. All right. So x is equal to x naught plus vx naught t. No acceleration in the x. Y is equal to y naught plus, plus vy naught t minus g t squared over 2. Now there's a couple ways to approach this, but let's, he does not, first of all, he does not give you the x and y axis. So it just so happens that if I make x here and y here, then x naught equals to y naught equals to 0. However, if I did something silly and said move the axis to there, then in fact y naught is not equal to 0, y naught is equal to 4, which would put a number right there. Guess that's okay, but that's not, I just want to go ahead, all you have to do is you just have to choose one. In this particular case, I'm going to go ahead and pick that, and this means that my equations break down to this. Um, at that particular point, if you're really looking at it, it's a lot simpler than you think. Now, there are cases in which you might want to learn the equation of this line. Y is equal to ax plus b. In this particular case, rise over run is minus 3/4 x, and the intercept happens right there, minus 4. So if you put in x equals 0, you'll get your minus 4. If you put in, another term, another location down there, you'll get the equation of this line. Now, you could parameterize this or get rid of the parameterization. In other words, you could do this and turn around, stick this back in here and right there. However, the problem is constructed such that it's even easier than doing that. Here's what I mean here. And this is a rare case in here. So if I look at this, what is x at point B? And it's, think about it like this. Times 20 is equal to okay. So what I did is I turned this to match that. So x would be 80, yb would be minus 60 minus the 4. You got this, and then you move down 60, which is minus 64. So your next goal would be Vx naught here. Here, just hang on a second. Vx naught equals to Va cosine of 20 Va sine of 20 to, hang on, Va sine of 20 but he wants you to determine that and determine the time of flight. So guess you could come back here, take this equation down, and say, combining these and these and these all together, xb would be Va cosine 20 times time, which actually I could just put in 80. Tell you what, do it this way. VA sine of 20t, putting this in here, or sorry, this in here, minus, now this is in meters, SI system, so minus 9.81, that's the G, t squared over 2. Just so happens the YB was minus 64. So if you stare at this for a little while, you'll notice a couple things. A couple things are, one, you have two equations, and two, you have an unknown that's VA, and you have an unknown that's T, I almost said T squared, but T. And so, how do you find that? Well, I guess there's a couple ways. One, you've got a similarity right here. With these two. So what I could do is do this. Let's see. And I'll do Control C. I'll move down here somewhere. Control V. Now I'll start messing with this. And I'll move this term over to here to give myself the space. The other thing I should do, well, let's do this, cosine 20. Now what I'm going to do, there are many ways to do this. Now I'll multiply this times cosine 20. Wait a minute. Cosine 20. Here. And now what I'll do is put a minus sign here and a minus sign here and add these two equations. What I should see is, if I add these two equations, if I'm seeing this correctly, I think I would see that I'd have a sine of 20, cosine 20t in a VA. So I think what I get is minus 80 sine of 20 minus 64 cosine of 20 equals 2, and then minus 9.81 t squared over 2 cosine 20, and I should be able to finish this out and get t. I'm not sure I want to finish it completely out, but if I did, I should be able to finish it out, get t, then turn around, I guess, and go in here or here. I would do both and make sure I get the same VA from both. Now, that's one approach. Secondary approach, let's try this here. So let's try a second approach over here. The second approach basically says this. I've got this equation is that line. Let me see if I can just use my Control copy, and I'll just drop it, say right there. So there's that equation. I also see, and maybe I'll just write this set of equations. Or maybe I'll do it this way. I have another set of equations that come from right here. Okay, so there's one equation. Here's the second equation. X is equal to VA cosine of 20 degrees T. Y is equal to VA sine of 20 degrees T minus 9.81 T squared over 2. If you look at these two, what you'll see is this equation is simply that line. What you'll see is these equations will map out the upside down parabola. And so the intercept between these two, this one you're not interested in, this one you are. So what you've got in this is parametric equations. Parametric meaning there's a parameter in which both of these follow. That is not what I'm interested in doing. I'm interested in having this because that is what I've got here. So what I do is I take t from the first equation and say t is equal to x over VA cosine 20, and then I stick it back in here and right in there. And so then I'll get the function that is the parabola, upside down parabola, upside down because you have a minus sign right there. And what I end up with is VA sine of 20x over VA cosine 20. This came from putting this together with this. And then I get minus 9.81. But then, and I can put a 2 here. And t squared, I get x squared over VA squared cosine squared 20. Now herein lies the difficulty of this approach. Okay, it is true this will cancel that, and what I'll get is tangent of 20 degrees x minus 9.81 2 x squared VA squared cosine squared 20. Now, where they hit each other, these two locations, all I have to do is take this equation, set them equal to minus 3/4 because the ski slope is sloping down, x minus 4. Now, ordinarily, we would solve for x and I'd get two solutions. One would be here, the other one would be there. However, in order to do that, I would need to know that. So that pretty much limits me and makes it not possible to do it easily. You can start guessing and working it out, but the other thing about this is that we already know that when it hits down there, it's 80. So it sounds bizarre, but I can put in one of the roots, meaning if I put in x is equal to, was it 80? Let me go back and check. if I put in x is equal to 80, this point is at x equal to 80, y is equal to minus 64. And y is equal to minus 64, then this equation must be satisfied. Which means if I just came in here and did that, that would fulfill this, that would fulfill this, and that. And then I could extract out the y sub a. Not easily, but I'd have to move things over and get the y, I'm sorry, not y sub a, v sub a. So you actually have two approaches, one significantly easier because all you're doing is identifying the point here, and you're going in, you're taking the equations, and you're saying, hey, you know, these equations must satisfy this. When you're doing this particular way, you are using the equation of a line, you're just using that point right there. The other is to set up the whole equation and then use it that way. Either one's fine. Let's see. I'm trying to see what time it is. Okay. Let me look at one more, and then we may, let's see, there. Okay, this is a similar thing. They all become kind of the same. Here, I'll go ahead and hammer this one out. Wait. Nope, that's not it. There we go. Okay, give me a second. Okay, then get rid of this. Now, I need to get the words in there. Okay, here there's a snowmobile. Dude is traveling 10 meters a second, leaves the embankment at A. Determine the time of flight from A to B, from A to B, and then the range. This is a case in which the line from A to B, y would be the slope. Rise over run, sloping downward. Intercept, now the intercept is based upon where you put the coordinate system at. I'm just going to put it right there. Okay, so if I do that, that's the equation of that line. Now, the equation up here, Vx naught t, because y naught is equal to x naught is equal to 0, because I put my origin right there at the point where time is equal to 0. Y is equal to Vy naught t minus gt squared over 2. Already I realize that this can be written and injected back in here to take a parametric equation and get rid of the parameters. Naught over Vx naught t minus g x squared over Vx naught squared over 2. Suddenly you've got this equation, which if you force to equal that equation, you get minus 3/4 x is equal to Vy naught over Vx naught t minus g x squared. Might as well put this down with here, 2 Vx naught squared. And it's possible I may have made a mistake because I've gone fast by, but here's your equation. And when you look at it, you realize, wait a minute, all I need to know, Vx naught is equal to V, which is just called V. It's 10 meters per second, which is 10 meters per second times, okay, here's what he's doing. This is 10. He's told you it's 10. He's told you it's 40 degrees. So you get Vx naught, Vy naught, 10. The x component, cosine 40, Vy naught equals to 10 sine of 40. Inject this one right in here, that one right there, this right here. Oh, and put in, this is meters per second, right? Yep, meters per second. So put in 9.81, and what you end up with is 3/4 x equals to Vy naught, which would be 10 sine 40 over 10 cosine 40 t x, this should be x right here, and should be x right there, x minus 9.81 x squared over 2 times the number 10 cosine 40. Now, first thing you see is there's no constant term. So therefore, I could put these two together. I could just say 3/4 plus, this will be end up being tangent of 40 x. So I move this one over here. I leave a 0 over here. Minus 9.81 over 10, 2 cosine 40 x squared. So now all I have is 0 is equal to one constant, x, minus another constant, x squared. So with that, I can take out one of the x's. Yep. And one of the solutions should be x equal to 0. Well, if you look at it from a mathematical standpoint, what you're doing is you're taking a parabola, you're finding the two intersection points. Well, yes, there's one intersection point. The other intersection point would be where C1 minus C2x is equal to 0, or moving this over, C1 over C2. That should be the x location, or the range right there. That's not typically called the range, but yeah, maybe it is, just kind of depends. That would be the x value, and that's it. So I'm going to go ahead and call it a day. It's a little bit earlier, but I sped through there. It's 9:32. But that does complete both of those, and this lecture will end up being saved out there. Let's see. Because we made our way through all 3 of those. Did that one in class the other day. So there we go. Oops. I did open up the next week. If you go up here and look, you should see, first of all, if you go to the live link, you should be able to easily drop down. Now this is going to be different than what you see because I'm the person who owns it, so, but you can click there. You can click and see live now and then past streams. Of course, this will be in the past streams. Oops. Live now. That's what's going on right now. But anyway, what I wanted to get to was to show you that I opened week 5. So week 5 is open. I think Blackboard gives you a post. And so that's pretty much it. So I'm going to call it a conclusion and say we're done.